There you go. All right. Thank you for reminding me about that, Sadie. Appreciate that. So here's example one in terms of solving logarithmic equations. Okay, so here's example one. This first one is shown right in your book. Okay, and then we're going to go through about three other ones for example one. Okay, logarithm of 36 to the x equals 3/2. We want to rewrite that in logarithmic, in exponential terms. So what we do is we keep the x on our left side. We move our 36 to the other side, because when we look at that, we basically what that's saying is 36 to the what power equals x. Okay, if we were to just look at my logarithm right there, it would be 36 to the what power is x. Okay, so then we rewrite it here, x equals 36 to the 3/2. And then when we have this, we rewrite this. Okay, so we have x equals 36 to the 1/2 raised to the 3rd power. So we pull our numerator out to make a power of a power. Here we have 36 to the 1/2 would be the same as the square root of 36, which basically would be x equals 6. So 36 to the 1/2 is 6. To the 3rd power equals 216. Okay, equals 216. And so you can see this example in example one. So that's the example they show you in example one. Okay, next one. Log 8x equals 4/3. We rewrite as x equals 8 to the 4/3. Okay, rewrite that, x equals 8 to the 1/3. And we pull our numerator out to make a power of a power. 8 to the 1/3 would be 2 to the 4th power, which equals 16. Okay, which equals 16. All right, let's take a look at another one. Same thing. Okay, log 9 to the x equals 3/2. Okay, we rewrite x equals 9 to the 3/2. 9 to the 3/2. We pull our 3 out. It would be 9 to the 1/2 raised to the 3rd power. 9 to the 1/2. That's the square root of 9, which would be 3. 3 cubed. X equals 27. That one is guided practice. What is that? 1A. All right. And then the last one for example one, log 16 to the x equals 5/2. Rewrite x equals, we bring the 16 to the other side. X equals 16 to the 5/2. Rewrite by pulling the 5 out. The 16 to the 1/2 is the same thing as square root of 16, which would be 4 to the 5th power, and 4 to the 5th power would be 1024. Okay, so solving logarithmic equations. So that's example one. Now let's look at example two. Okay, here we have, okay, where we're again solving logarithmic equations, but here we have logarithm on both sides. Okay, logarithm on both sides. This is similar to when we had exponents and we had if 5 to the x equals 5 to the 6, if we have the same base, we simply put our exponents equal to each other. X would equal 6. Okay? And so we do the same thing. We use the same property with logarithms. If we have the same logarithm here, we then can put our terms here equal to each other. So then we simply have x squared minus 4 equals 3x. Now, when we solve for this, we have to recognize that we have a quadratic term here. Okay, quadratic term here. And so we need to set it equal to 0. So we're going to subtract 3x. So now we have x squared minus 3x minus 4 equals 0. When we have our trinomial here, we're going to break it factors. Okay. X. With that being a negative, one's going to be positive and one's going to be negative. We recognize if this is a negative 3, then our bigger number of my factors of 4 need to go there. So then once we solve x minus 4 equals 0, x plus 1 equals 0. So x equals negative 1 and x equals 4. Now, once we have our solutions here, we need to plug them back in our original equation to see if it makes sense. Okay, because we can't have a negative up here. Okay, so when we put in negative 1, negative 1 squared is 1. 1 minus 3 would be negative 3. Negative 1 here. We can't have a negative 3. So negative 1 is going to be what's called our extraneous solution. Okay, that's going to be an extraneous solution. Okay, and you can see that in example 2. When we plug 4 in, 4 times 3 is 12. 4 times squared is 16 minus 4 is 12. So 12 equals 12. So my solution would be 4 in that example. Okay, my solution would be 4. So we always have to check for extraneous solutions. Okay, let's try another one. Okay, log 3. Then we're going to just put these two equal to each other. Okay, x squared minus 15 equals 2x. We have our quadratic term, so we need to set it. Anytime we have a quadratic, again, we want to set it equal to 0. Subtract 2 from both sides. Excuse me, 2x from both sides. Now we have to factor. Okay. Again, xx, one's going to be positive and minus. With the negative 15, one's going to have to be a positive and one's going to have to be a minus. Now we're looking for factors of negative 15. Well, 15 and 1 or 5 and 3. Well, 5 and 3, there's a difference of 2, right? 15 and 1 doesn't bring us up with a difference of negative 2. So we're going to put a negative 5 and a 3. And if we were to factor this, x times x is x squared. X times negative 5 is negative 5x. Plus 3x is negative 2x. 3 times negative 5 is negative 15. Okay, so now we've set these equal to 0. That's going to be 5 and negative 3. When we plug in negative 3, we have a negative number up here. Negative 3 is going to be extraneous. When we plug 5 in, that becomes 10. 5 squared is 25. 25 minus 15 is 10. So my solution, x is going to be equal to 5 on that one. Okay, 5 on that one. Let's take a look at one more. Okay, let's take a look at one more. Okay, again, we recognize same logarithm. That means we can just take the terms and put them equal to each other. Okay. We have a quadratic term. Move these. We could move this to this side, but always keep your x squared positive. Okay, keep your x squared positive. It'll make it much easier to factor. Okay, so we add 6x and add 8. X squared plus 6x plus 8 equals 0. Okay, we're going to factor this. X plus, when both of those are plus, my operations are going to be plus and plus. Factors of 8 when added up to equal 6 are 4 and 2. Okay, so our solutions would be when we put both of those equal to 0, we end up with -2 and -4. We want to plug those back in. So we plug these back into our original equation to see if we have an extraneous solution, one that doesn't work. If we plug in -2, -2 squared is 4. -2 times -6 is 12. Minus 8 is 4. Okay, so that's going to be a good solution. When we plug in -4, -4 squared is 16. -4 times -6 is 24. Minus 8 equals 16. Okay, so both of those, even though the answers here were negative, once we plug them back in, there was no negative up here. Okay, there was no negative up there. And so they were both solutions on that. Okay, so that was example 2. All right. So here's example 3, bottom of page 479. Okay, bottom of page 479. All right. So we know we can't have a negative here. Okay. So when we have an inequality, okay, this cannot be a negative. Okay. So x needs to be greater than 0. Okay. We know that x needs to be greater than 0 because when we rewrite this, x greater than 3 to the 4th power, right? Just like what we did in example 1, except it's an inequality. Okay, it's an inequality. Because we have an inequality, we have to check for any restrictions on this number. So 3 to the 4th power, x needs to be greater than 81. But because this says x needs to be greater than 0, is our solution here greater than 0? It is. So this is my solution. We just have to check this solution to see if it makes sense. Okay. So let's check on this one. Okay. So let's check this one again. Okay. X needs to be greater than 0. Again, that term needs to be greater than 0. Rewrite it in exponential form. X greater than or equal to 4 to the 3rd power. X greater than or equal to 64. Okay, well, this is my solution I came up with. My solution needs to be greater than or equal to 64. this doesn't come into play in this instance. So now let's take a look at, this is guided practice 3B, bottom of page 479. Bottom of page 479. Okay, so again, we have an inequality. So therefore, whatever this term is, x needs to be greater than 0. Now let's solve it. X less than 2 to the 4th power. X less than 2 to the 4th power is 16. So here we have x is less than 16. Well, negative numbers are less than 16, but we know that x needs to be greater than 0. So my solution set is going to be 0. X needs to be greater than 0, but x also needs to be less than 16. That's when this restriction, that's when this restriction comes into play. Okay. So this is going to be your solution, because we know that x needs to be greater than 0. Even though here says x is less than 16, we can't have negative 25. We couldn't put negative 25 in here. We can't have a negative number up here. Okay, and so we're going to look again at that with example 4. So turn the page to 479, or excuse me, 480. Okay, 480. Again, with an inequality, we can't have this number be a negative, and we can't have this number be a negative. Okay, so we put x plus 3 greater than 0. So x needs to be greater than negative 3. So we know x needs to be greater than negative 3. We would do this, 2x plus 1 greater than 0. Okay. Solve for x. Subtract 1. 2x greater than negative 1. X greater than negative 1/2. So those are my two restrictions, okay, based on what's up here. Well, if x needs to be greater than negative 3, but here x needs to be greater than negative 1/2, we know it needs to be greater than negative 1/2. So we don't need to use that one as a restriction. This is the only one we need to use as a restriction, okay? So x is greater than, so x needs to be greater than negative 1/2. Okay, so now once we've figured out that restriction, we have the same logarithms here. We now just put those two terms with our inequality. Okay, so now we have subtract x, subtract 1, cancel, cancel. 3 minus 1 is 2. Greater than x, okay? So here we have x needs to be less than 2. And we can rewrite this as x less than 2. But we also know that x needs to be greater than negative 1/2. So we know that it needs to be greater than negative 1/2. So my solution set would be negative 1/2 is less than x, which is less than 2. And you can see that problem. That is example 4. Okay, that's example 4 on page 480. Okay, and take a look at that and go through what those restrictions might be in terms of what your solutions are. All right, so now we're going to do guided practice 4. Here's guided practice 4. Okay, so we have here we know that that needs to be positive. 2x plus 1 needs to be greater than 0, and x plus 4 needs to be greater than 0. X greater than -4. Here we're going to have -1, 2x greater than -1. X needs to be greater than -1/2. Okay. So we're going to have this same thing. If it needs to be greater than -4 or greater than -1/2, this is the one we're going to use. So we know that x needs to be greater than -1/2. Now we're going to set our inequality. 2x plus 1 less than or equal to x plus 4. Subtract x. Subtract 1. X less than or equal to 3. So here we have x is less than or equal to 3, but x also needs to be greater than -1/2. So we always have to start off with these two to see what restrictions we might have with my solution set. Okay? So that is lesson 7.4. Tomorrow, stay on the line if you have any questions on that. I will hook up this, what we just went over, onto Google Classroom. Tomorrow, I will release the review. And then Monday, I will give you the test on Monday. All right. So if you have any questions, go ahead and stay on the call. Other than that, tomorrow, you don't need to show up tomorrow. I will be here for your assistance if you need. If not, we will shout at you on Monday.
Thank you, Mr. Pepple. See you.
Guys. Peace. Have a good weekend.
Thank you.
Bye.
Any questions?